All right, everyone. Today I am here to go over the Studio One that you just did in class yesterday. I like to record these videos after Studio is over for the week just to go through, how I would complete these studios. It doesn't have to be the same way that you do it. In fact, that's one of the things I love about computer science is there's often multiple pathways you can take to get to your destination. But I do think it's useful, especially if you aren't able to attend studio or don't complete the studio in the amount of time that we have, to be able to see a full, complete walkthrough of a solution. So that's what we're going to do today, starting with the very basics. I'm going to import the repository into Eclipse. So this is something that I would imagine most of you have probably not done before you've taken this class, but repositories are containers for our code, basically. And you're going to get used to this process as we go along because every assignment, every studio is going to have its own repository for that particular piece of code. This is pretty standard practice just to keep everything organized. And the way that we do it is by grabbing this link here from github.com and then going over and starting the import process in Eclipse. So the way I do that is usually just by right-clicking and going to import. This is a Git project. Yeah, you can use either one of these. I think it doesn't really matter all that much. And then you can select the clone URI option. And then my username, and this is not my password, but a personal access token, has already been remembered by Eclipse, and the URL gets posted here. So we're ready to click Next. This screen just tells us what the branches are. Usually there's only going to be one, so we'll go ahead and hit Next. Here we see actually a very common error. It says that this is not an empty directory. What this means is that I've already tried to access this studio before, which is true. I've gone through this studio many times over past semesters, yeah, it sees that I've already tried to do this and it's like, I don't want to actually erase anything that you want to keep. So all we need to do to fix this problem is give it a new name, give it a new place to go. So I'll say, Spring 25, just to make sure that I know which version of the Studio One review this is, and then hit the next button. And then finally we'll hit the next button one more time before we hit the finish button, and that successfully imports our studio into Eclipse. I first expanded, this is called the project, then I expanded the source folder, and then finally there's a package in here called Studio One that contains our Java files, and these are where we're going to be doing our work for the studio today. So yeah, we can now switch over to the studio instructions. These are the instructions that I just went through about how to get everything into your repository, and we're ready to go ahead and start doing some work. So the first one that we have you take a look at is called Hi One, and so if we pull that one up, it says say hello to the supplied argument. So this is what creates what's called a scanner. A scanner is used to read in input from the keyboard. The next line here describes what I would call a prompt. We're actually, asking whoever's sitting in front of the computer to type something in. This is actually a bad prompt. I would say we should probably change this to say something a bit more descriptive, give the person, a better idea of what they need to type in. So I would probably say enter your name is a better way of phrasing this. And then this line here is going to read in whatever gets typed by the user and store it in a variable. So this is how we declare variables. First, by specifying the type. Since we are asking for a name, it makes sense that we're using the string type here, since strings represent text. And then this is the name of our variable. We've called it name, but this can be anything that we want. So we could call it username or whatever variable name we would like to select, but it is good to give it something descriptive so that when we look at the code we know what this value is supposed to represent. So we can actually run this code. I know we haven't completed the exercise yet, but we did change a little bit, and we can at least see how this works before we try and complete what's being asked of us. If I run the code, you'll see there's my prompt. It's now waiting. It's actually here on line 14. It's now waiting for me to type in my name. So I'll do that, and then once I hit enter, you see that actually nothing happens because if I look, I haven't told it to do anything. So that's sort of our next task. We want it to say hello to whatever got typed in by the user. So I typed in my name, Doug. I want it to say, hi, Doug. But if I type in a different name, I want it to say hello to that different name. So we need to write one more line of code down here. We're going to write what's called a print statement. And then within this print statement, I'll say hello. But we need to add the name of the person afterwards. And the way that we're going to do that is by performing an operation. Now this looks like an addition sign, but remember that the operation that's being performed depends also on the types of information that are being used. So I'm not really adding the strings together, since the value on the left-hand side is a string, the value on the right-hand side is a string. What I'm actually doing is an operation called concatenation to combine these two strings together. If it was numeric values instead, such as ints or doubles, which we'll probably see in a little bit, then it wouldn't do that, it would do addition. But since we're using strings, the operation is actually called concatenation. And it just sticks those together. Notice I put a space in here to make sure that it actually puts a space in between the words, and I'll be careful to do that on this side as well, because it wants us to say, how are you as well on the back side of this. So I'll tack that on the end. I have to remember my semicolon to finish that statement. And now we can go ahead and try this. I'll type in my name again, and it says, hello Doug, how are you? Oh, I apparently have turned on, that's interesting. Why did it do that? I don't like that it did that. Huh. I think I hit a strange button somewhere. I'm not sure exactly what. Oh, I think it's this one right here. Oop. No, that's not it. I'm gonna Google this real quick. I'm sorry this happened, but I think what it's called is coverage highlighting. How do I turn this off? This is a very common thing. Window, show view, other. Okay. Window, show view, other, coverage. Here we go. I'm gonna open that, and I want to turn it off. How do I turn it off? There we go. Fixed it. Alright, sorry about that delay there. I'm not really sure how that happened, but I was able to successfully fix it. Honestly, I'm not unhappy that it happened, and I'm going to leave it in the video because it's a good illustration of the fact that there's a lot of stuff going on here. I've talked to a lot of students about this actually in the first week or two, and I just want to validate that feeling, especially if you're having it right now. There's a lot happening. We're throwing a lot of information at you. Eclipse does a lot of stuff that you've probably never heard of before. The stuff that I was just struggling with is something that you've probably never seen or heard of before, although students have run into that error before. That's kind of how I know how to fix it, because I have seen that particular problem before. How did it happen to me, though? I don't know. Sometimes weird stuff just happens on the computer, and you got to figure it out. That's kind of the spirit of programming is, let's figure out what the problem is and try to fix it. But also, we're here to help you if you get super stuck and really can't figure it out. Anyway, let's try it again. Hopefully it's not going to do the same weird thing that it did last time. I'm going to try a different name this time. I'll type in my son's name, and there we go. Hello, Simon. How are you? Notice that actually this isn't correct, right? I stuck an extra space in there. I should probably take that one out to be more grammatically correct. Let's try that one more time. Say hello to my daughter, Pearl. There we go. Perfect. Maybe I need a comma there, but that's okay. I'm going to call that good enough for this one. We can tweak the formatting all day. Let's move on to the next exercise. We now want to do the same thing, but with four names. So we're going to move on to the file that's called hi4. We can see that there's now repeating this process 4 times, and I'm actually going to take the time to say, enter name 1, just to make this clear what's going on here. Name 2, name 3, and finally name 4. And you see we've got the same process. We create the scanner, and then we're able to reuse the scanner to read in 4 different variables called S0, S1, S2, S3. We now want to say hello to all of them. So like we did before, we're going to do a print statement down here, and we're going to use concatenation. I'll say hello S. Oh, I forgot something. I need to put in the plus sign. That represents the concatenation. So hello S0 plus a comma, followed by S1, followed by a comma, followed by S2, followed by a comma, and then finally S3, and I don't need a comma after that one because that is the final name on our list. I believe that line should do it, but we should totally check it out and see what happens. Let's do John, Paul, George, and Ringo, and there we go. Hello, John, Paul, George. If I wanted to, I could and perhaps should put it right over here, just to insert that word at the end, just to make a little tweak to the language. But otherwise, the concatenation, that repeated concatenation, is what we need there. A little tedious, perhaps, a little even annoying, I would accept as a valid response to having to do that. But computers are very literal. We have to speak to them very exactly, very precisely, or they won't do what we say. If I forget even one of these plus signs, then it tells me about it. It tells me it's upset and makes me fix it. So have to be exact, have to try and think like a computer and say things the way that the computer expects us to say them. Let's go ahead and move on to the next one. This ordered is going to be our next destination. So if we take a look at this one, it's reading in 3 values. So we're now no longer talking about strings, we're talking about numeric values, specifically ints. So that was one of the 2 numeric types that we saw. And we're checking to see if these are in order. I want to see if these are in order either ascending, so x is less than y is less than z, or descending, x is greater than y is greater than z. So we're going to go ahead and try and create a variable to represent that using a type called Boolean. Boolean is a special type that represents only 2 values, either true or false. And so the idea here is that these are either ascending or descending, and if either one of those is true, then we can say that those are in order. In fact, I kind of want to break it down a little bit, right? Let's first check to see if it's ascending. And we know that if the values are ascending, if x is less than y is less than z. And if we were in math class, this would be a perfectly legitimate way of thinking about things. But this is not the proper way to talk to the computer. Consider that when it sees a sign like this, it's going to compare the thing on the left to the thing on the right, and then return a Boolean value for this entire expression. So either this is true or it's false. So if x is 2 and y is 3, this is going to be true. And so it'll just replace this entire thing with that value, true. But then over here, I'm trying to do one more comparison, and I don't have a proper value over here to compare it with. Or another way of thinking about what I just said is that this operator right here, greater than, less than, equal to, which we call relational operators, require 2 things, 2 numbers on either side. So I'm actually performing 2 comparisons, right? So I need to say that x is less than y and y is less than z. So we're getting closer here. I just need something that I can use to stick these 2 things together. And for us today, that's going to be the AND operation. Again, this is a Boolean operation, not a relational operation, but rather a logical Boolean operation that says, this entire expression is true if the thing on the left is true and the thing on the right is true. If either one of these is false, or both of them, then the entire thing will be false. In fact, we often write that out in something that's called a truth table, which I know is in the textbook, but I'll do the one for and here very quickly. There's only 4 possible outcomes. It can either be true and true, which is true, or it can be true and false, which is false. It can be false and true, which is false, or it can be false and false, which is false. So the only time that this AND operation is going to give me a true value is if the thing on the left is true and the thing on the right is true. So that's only going to be the case if x is less than y and y is less than z. Let's try that real quick and just print this out. I know we haven't finished the problem yet, but let's see if at least this part is working, and then we can add on to it and try and do some more. I'm going to run this program and try some values that I know are going to be ascending, like 2 for x, 3 for y, and 4 for z, and see that it prints out true. And if I try values that don't work, so like 4, 3, 2, it says false. So that part appears to be working, but this should also be true, so we need to pick up the descending case as well. One way we can do that is actually very similar to this, right? We want to do the same thing, except just in the opposite direction. So I'll actually just kind of copy that line and flip these signs to say greater than, and I believe that will take care of the descending case, right? But I don't want to print out, 2 of these values. I just want to print out one value that says whether they're ordered. So I know that they're ordered if this is true or if this is true. And so I can use another logical operator to compare these two things. This entire expression will be true if the thing on the left is true or the thing on the right is true. There's actually a truth table for OR, very similar to the one for AND, except for the values are different, right? OR returns true if the thing on the left or the thing on the right is true, meaning that if it's ascending, I'll see true here, or if it's descending, I'll also see true here. If it's neither, then I'll see false. This symbol, by the way, is called a pipe, and it's usually found above the Enter key on your keyboard. Not one that people are using outside of programming all that much. But let's test this program a couple more times before we move on to the next one. I'll say 2, 3, 4, make sure that one works, and then I'll run it again with descending, 4, 3, 2, that also is behaving appropriately, and then if I do one that's neither, like 3, 4, 2, I get false back out. And that's an important step as well, running the code, testing it, make sure it actually is behaving the way that you want it to and you expect it to. Alright, great. We do still have, I think, 1 or 2 more exercises to do. So the next one on our list is called average. And for this one, we didn't give you anything to start with. We're asking you to create a brand new program, a brand new class that creates Java code. And the way that we're going to do that is by right-clicking on this part right here. Remember, this is called the package. We'll go to New and then select Class. And the name of the class is going to be called Average. I almost always forget to do this step, but this time I remembered to check this box, which is going to create the main method for us. I know that's something that might seem a little mysterious, but we will talk about that in more detail as time goes on. Then I'm going to go ahead and click the Finish button to get things going, and we're now ready to start writing code. And so if I refer back to the directions, the first thing that it's going to ask us to do is read in 2 integers. It's asking us to call them M1 and L2, and then average them. So it's going to average those 2 integers and print out the result. Okay, let's take a stab at that. Now, the first thing we need to do is ask the person to type something in, and honestly, I'm going to go back to this one right here and borrow some code. because we've already got the code to set up the scanner and to ask the user to type values in. There's no reason I have to retype all that stuff. So I'm going to go back and grab code that I know does something similar to what I want. I'm going to copy it and paste it over here, and then I'll just tweak things a little bit. Right? Value for n1, value for n2. I can even change the variable names here to be n1 and n2. And now I just need to print out the average. How does it want me to? Yeah, it wants me to print out the average of blank and blank is blank. So I'll include a print statement down here that says average of, and we're going to do some concatenation. Again, because this is a string, we're not doing addition. Even though n1 is an integer, could be addition, but since this is a string, we can't really add strings, so that makes this operation be concatenation. And n2 is, and then we'll do, maybe I'll make a separate variable for the average. Int average is equal to n1 divided by n2. And then I'll plug that variable in at the very end here, and we can try it out. If I run this, I'll plug in two values like 5 and 6, and I'll see that, oh, I did a couple things wrong here. Okay, let's see if we can't figure out what went wrong here. I see that some of it is just I don't know how to compute the average correctly, and I forgot to, what I actually need to do here is add these and divide by 2. That's just me completely doing the average wrong, but that happens sometimes, right? Your brain just doesn't do the proper thing, and you're like, oh, that number seems really weird. Let me figure out why that number came out weird, and you got to go fix it. So that's one mistake I made. Let's try it again and see if there's any other issues here. I'll try 5, 6, and it says the average of 5 and 6 is 5, which is close, but actually, you know, the average is 5.5, and then hopefully that sets off some alarm bells in your brain. It makes you think that, well, okay, 5.5 isn't an int. 5.5 is a double. So really, this should be a double, not an int. So maybe we need to change the type here, right, of this variable to say double and not int. And I agree. I think that's a good thing to try. So let's run it again now that we've made that change. Let's see. Average of 5 and 6 is 5.0. Well, why? Why is that happening? Let's go over here and take a look at the math, and we're going to follow order of operations, try to figure it out. It's going to do the addition first because of the parentheses. That gets us 11, but the types matter. So that's kind of a reoccurring theme, right? The types matter. This is an int. This is also an int. An int plus an int is going to give us an int back in return. So I get an 11 back, but it's 11 as an integer. And then when I perform division here, right, I get 11 divided by 2, which should be 5.5, but this is an int and this is an int. So it doesn't give me 5.5 because 5.5 is not an int. It does, you know, the next best thing that it can and says, well, I'm just going to ignore the decimal. It does not round. It just says, I'm just going to ignore that decimal entirely and give you back 5, which is not what I want, right? I want it to be 5.5. So, you know, we made this a double, but it's too late. We actually need to do something here to make sure that it computes things properly. And there's a couple ways we could do it. We could, you know, change the types of one of these. We could change the type of this, which is a common way of going about things. If I just put a 0.0 on the end, this now becomes a double. And I believe that'll actually do it. It's probably my preferred way of solving this problem. 5 and 6 now gives me an average of 5.5. If you wanted to, you could also use a cast by typing the word double in parentheses. That's going to change this numerator into a double, right? So that it's no longer an int and knows that we don't want an int back. We definitely want a double. Lots of different options, but that's computer science. There's almost always going to be multiple ways of doing the same thing. Okay, I believe that we have one more left, which is this leap year one. We're going to make a class again. So let's go ahead and do that. I'm going to call it leap year. Oops, and I forgot to check the box that says to put in, the public static void main, but that's okay. I also need to ask the user to type in an integer representing the year, because that's what the problem is asking us to do, check for leap years. So, I'm just going to come over here and grab this code from before and paste it in here. I need to make sure I close that bracket. And I can change this prompt to say, type in a year, please. And actually, I probably should have brought in one more line, but that's okay. I can say int year is equal to in dot next int, and that should take care of reading in whatever year the user wants to check to see if it's a leap year. And now it's our job to check this value and see. Is it going to be a leap year or not, using the rules that have been defined here. So something is a leap year if it is evenly divisible by 4. I actually like to do this, one part at a time. We don't have to do it all in one go. We can do it one part at a time. So let's check and see if it's evenly divisible by 4. I'll say either it is or it isn't, right? So whenever something can only go one of two ways, that tells us that we can represent that with a Boolean value, is divisible by 4. And in order to check this, we're going to use an operation that you've probably not used a whole lot before now, but is very useful in this class and other programming classes, called modulus. The way that it works is I'm not going to do division here. I'm going to do a percent sign instead. That's the modulus operator. And if I say modulus 4, what it does is it divides it by 4, but it doesn't give me back the remainder. It doesn't give me back the result. It gives me back the remainder. So how much is left over? So if the remainder is 0, then I know that 4 goes into the year evenly and should be a leap year. If the remainder is anything that's not 0, then I know, that it's not a leap year. I need to check that. So if that is equal to 0, that's what I want to know. And I did this wrong here. You can see Eclipse is unhappy with me. This is an intentional mistake that I made, a very common mistake that I made. Single equals is used for variable assignment, taking the thing from the right-hand side of the equal sign and storing it in the thing on the left-hand side of the equal sign. What I'm trying to do here is ask the question, is this equal to 0 or not? It's a yes or no question, a Boolean question, and that's represented by a double equal sign. So we actually have to distinguish that from variable assignment. It's two different operations, so we use the double equals to make that distinction between checking for equality versus assigning something to a variable. And even though I'm not done yet, I'm just going to go ahead and print out is divisible by 4 here to see if I can at least check this first part to make sure that it's working. If I type in a value for like 200, that's good, but if I type in a value for like 201, that's not a leap year. Okay, so far so good, but we've got some more rules to check. And so the other rules that we need to check, it is not evenly divisible by 100. So actually 200 should not be a leap year, right? So let's do another statement similar to this to check to see if it's divisible by 100. In fact, I can go ahead and copy this line and just do some tweaking, like so. And then let me do the last condition, right? So an exception to this rule is if the year is evenly divisible by 400. So we also need to check to see if it's divisible by 400. Okay. So I'll do one final line like this, where I check to see if it's divisible by 400. So there's really kind of two ways to get at this, right? If it's divisible by 400, I know it's a leap year, right? If it's divisible by 400, I know it's a leap year. That is the exception to the rule. Or if it is divisible by 4 and it is not divisible by 100, it is also a leap year. So let's think about this statement. Try to break this statement down, right? I'm saying the year is a leap year if it is evenly divisible by 400. That is this exception right here. The year is evenly divisible by 400. These years are leap years. So if I detect that, then I can just say right away, that's a leap year. Or it's a leap year if it's evenly divisible by 4. And this is very important right here, the not sign, right? So if it is not divisible by 100, that means if it is divisible by 100, this will flip it, right, to be false and say that it's not a leap year. If it's not divisible by 100, this will be false, and this will flip that to be true and give this and a shot at also being true, since both sides have to be true. Let's try this out. We're going to try this out and see. I'm going to try the examples that are on the website, just so because those are easy to check. 2020 is a leap year. 1900 is not a leap year because it's this rule. And then 2000 is a leap year. So let's try those. 2020 is a leap year. That's good. 1900 is not a leap year because of the second rule. And the last one was 2000, which is a leap year because it's evenly divisible by... Oh, whoops. I forgot I hit the wrong button. Sorry about that. Is a leap year because it's evenly divisible by 400. Awesome. All right. I believe that does it for this week's studio. As I said, I just kind of like providing a walkthrough. But also, there is an assignment coming up. So next week in class, you'll be demoing your first assignment. It's a simple grade calculator based on the way that we compute grades in this class. So we actually refer you to the course policies page for information about how things are graded, and you're going to write a program that can compute your grade based on how you do on the various parts of the course. And it should be accurate based on how we compute the grade in your class. I would like to remind you, and I'll talk about this in class on Monday as well, that for every single assignment we provide a rubric. And so it's very important as you're going through the assignment, especially once you're done and ready to submit, that you scroll down here on Canvas and take a look at the rubric that's provided. We want you to look at this ahead of time. We want you to prepare. We want you to be ready to answer these questions, because that's what's going to happen when you sign up for the demo process. The TA is going to run through this one item at a time and ask you all these questions and fill out the rubric right there on the spot and tell you what grade you get on your assignment. So I will talk about this more in class on Monday. Just want to bring it to your attention now. For those of you who are getting started on this assignment over the weekend, that's going to do it for this studio review video. I hope it was helpful. I'll be posting these every week, as I said. So have a great weekend, everyone, and I will see you in class on Monday, where we are going to discuss the materials from Module 2. Looking forward to it. I'll see you then.